Hey everyone, welcome back. We are in the midst of looking at our 5 themes of geography. This time we're looking at theme 3, which is location. We've looked at place, we've looked at region, this time it's location. Okay, and I've actually made this whole video and realized it was going to be too long, so I'm going to kind of speed through it. So if you have any questions that you need things clarified, let me know because it's going to go fast. Okay. Pause it at any time if you need to read through the stuff, but location, 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 right? It is where something is, and that sounds really obvious, but there's a couple ways that you can specify location. Um, the two main things that we're looking at in this case are what are called absolute location and relative location. Absolute location is where exactly something is found. It's using a coordinate grid system, right? Latitude, longitude. We'll look a little more at that eventually. And then there's relative location. So where is something in relation to another place? It's similar to what we talked about the other day with situation, but this time it's called relative location. Okay? To represent the places that we look at in the world, we use a whole bunch of maps in geography, right? So this class is going to be filled with maps, map after map. And to use maps, there's a few different types of maps, but before we get into that, we need to decide, hey, what actually is it that we're trying to get across using a map? So you have to figure out what information you're trying to convey. Okay, who are you trying to target with your map? Once you've figured out what you're trying to convey, you have to figure out in what way you're going to do it, right? You have to figure out the neatest, simplest way to get the information across. And then you also have to decide how zoomed in or zoomed out that information is going to be. So that idea is getting at what's called scale. Okay, so scale is basically how zoomed in something is going to be, right? If you wanted to try to help someone navigate the hallways of Beloit, of the high school, right? You don't want a map that includes the entirety of North America because that's not going to be a helpful map. At the same time, if you are trying to compare the population of countries around the world, well, it doesn't make sense if you zoom your map all the way into the city of Beloit, right? That would just be foolish and it would not achieve the goal that you're trying to. So we call this scale, how zoomed something is, and there's two key ideas here, and those are small scale maps versus large scale maps. And it gets a little tricky, so make sure you're kind of paying attention. Make sure that this is making sense for you, right? Small scale maps end up showing a small amount of detail. It's zoomed way out. Okay, so the world map, right, includes the entirety of the world. So it might be scaled at a ratio of 1/1000th of real life size, or it might be 1/100,000th of real life size, right? So 1 inch on your map might be an entire country, right? That would be a small scale map. Okay, it means that you're covering a lot of surface area, but the trick that I always use is small scale map shows a small amount of detail. Okay, I'm not going to be able to put all the road names in on a world map. I'm not going to be able to put in buildings and every little tiny itty bitty city. Okay, so there's not going to be a lot of detail. In contrast, we have what are called large scale maps. Large scale maps are the closest to real life size as possible. I'll give you an example. You could make a map of your house, right? You could put a ton of detail on a map of your house, right? A large scale map would have a large amount of detail. So you could put furniture on a map of your house, right? Here's where my dresser is. Here's where my bed is. Here's where there's a lamp, okay? You could even put outlets. Well, if you had a world map, I'm sorry, but you're not going to be able to put the beds and the furniture in on that map. So small scale map, tiny amount of detail. Large scale map, large amount of detail. Okay, so let's actually get into some of the map types now. Okay, and these being underlined and in bold, you'll want to write them down. We will go through them individually, so you don't have to write them right this second, but as we get to them, if you need to pause and write, you can do that. So in this class, we'll be seeing a ton of maps, like I said. There are what are called reference maps, which are super simple. I'll show you one in a second. And then there are what are called thematic maps. Those are the maps that have some sort of theme. They have a purpose. There's a goal or a message or data that I'm trying to get to you. And beneath the thematic category, there are four main types of thematic maps. So let's start though first with the reference map. It's a category in and of itself. A reference map is the basic map that shows major places, and then just like the roads that connect from place to place, and the main geographic features. Like you can see here, there's rivers, you can see lakes, you can see the ocean, okay? And then you can see the highways and interstates and stuff like that. So a reference map is a very simple old school map. The only goal of a reference map is simply to help people navigate from one city to the next. That's pretty much the only thing, right? We're not trying to show statistics and amount of goods produced in a place. It's just a simple, straightforward map. Whereas a thematic map, okay, is the other type, and in this case, it shows a theme or a topic over whatever geographic area we think is important, right? So if you want to know the number of people per square mile, we're going to break out a thematic map. You want to know the amount of oil produced in a country, the average rainfall in a country or a state or whatever it happens to be. Anything, any data or information that you want to get across to people, you can pretty much turn into a map. Okay, so here's the first of the four types of thematic maps that we're going through. The first one is called a Choropleth map. Okay, I put it all colorful because that's what it means, right? It's getting your data or your information across using some degree of a color. It could be different colors, or you could literally have a black and white map and just have like the darker the black, the more of that thing there is in that area. The lighter the shade of, light shades of gray might be less of that thing. So in this case, right, it's life expectancy. Both these maps are about life expectancy. This one here is a small scale map because there's a small amount of detail, right? It's zoomed way out. And then this one is a larger scale map because now it's broken down by country, and it's life expectancy. So the darker the color, the longer people are living. Well, at least in this one. In this one here, it's redder colors mean people have a higher life expectancy. So it always requires that you have a map key to help people interpret what your data actually means. The second one we call a dot density map. In this one, it uses dots to represent how much of something there is in that place. Again, you can zoom it in or zoom it out to wherever in the world is your goal. So this one is population density, right? How many people are packed into a certain area. So each of these, you can't see the individual dots, but each itty bitty microscopic dot might represent 10,000 people or 50,000 people or something like that. So the darker it is, or the more packed together these little itty bitty dots are, the more of that thing there is. Okay. The next one, this one's not a super common map either, but it's used for specific things. Typically, it uses rings or like arcs or lines. Hence the name isoline map. It has the word line right in it. An isoline or isoline map connects parts of like one similar theme. So I use a couple examples here. I'll get my face out of the way. Average temperature could be connected by one line or arc. The feet above sea level, right? Elevation could be represented. It could be inches of rainfall. If we look to the left here, this is rainfall in Australia. You have, right, in all of this first arc here in yellow is a certain amount of rainfall. It's very little rainfall. And then this next ring, you get more rain, more, and more, and more. And so that's kind of how you read that. This top one here, different arcs and wavy lines and stuff to represent different elevations. So the height above sea level. Okay. The next one we have is called a proportional symbol map. Right. A proportion is kind of, again, it's like scaled in or out, but it's some sort of symbol. Now this one's mostly just using circles. But you could use, if you want to figure out which state produces the most corn, well, then on each U.S. state, you might have a big corn cob if it's like Nebraska and they're producing a ton of corn, and then a tiny little itty bitty one for a state that doesn't produce much corn at all. This one is roller coasters in the United States. So if you're big into roller coasters and amusement parks, go to California or go to Ohio. But if you want to go on a roller coaster, you do not want to go to, it looks like, North Dakota or Montana, because you're not going to find any there. Okay. This one here represents refugees from Syria. Which countries did they go to? So a lot of them, it looks like, went to Turkey, and not so many of them went to these other countries. So that's kind of how proportional symbols will work. A lot of times it's a circle. That's the most basic, but it can be any number of things. It can look like this. This is population. This one, they actually replaced the countries with circles, so that's another way you can do it. And then my personal favorite map, it's super wacky looking. It's called a cartogram. Cartograms use proportional information as well. So in this case, and I know my face is in the way again, but it says this map shows billionaires per state. So it looks like there's 99, at least at the time of the making of this map, there were 99 people in California who are billionaires. So they literally take the state of California, which the shape of it is barely even recognizable here, and they blow it up like an overinflated balloon. Okay, but then you take like Washington or Montana or Nebraska or something, where there's not many, if any, billionaires, and so those states get shrunk way down. Okay, so it ends up looking really weird. I don't know that the cartogram is ever like the perfect representation of anything. I just like them because they're kind of fun. You can see population in the world, right? Here's a regular map. This is how a regular map would look like. And then over here is a map that's a cartogram. So it's population. So they took China, which is has the most people in the world, and they made China humongous. And India, which has the second highest amount of people in the world. And even though India is a fairly small country, relatively speaking, they blew it way up because they're trying to show that there's a lot of people who are living there. Okay, and some places like the United States, proportionally, the size of the United States on this map didn't really change a whole lot. Okay, and just a couple more concepts to get through, and then we're donezo. So those were the 4 different types of thematic maps. Now into a different topic entirely, kind of, but it still goes into the making of the maps, right? A lot of the maps that you use on a daily basis, especially if you're like navigating, like you put something in your GPS, Google Maps, you use your phone and it gets information from satellites way up in space, right? We park these satellites in space. It's all fancy. That's how you get your, sometimes it's internet through satellite, sometimes you get TV through satellite. But your phones are always connected to them. That's how it knows your location. So the idea of using satellites to look down and gain information, to gather information, it's called remote sensing. Remote means from a distance, right? When you change the channels on your TV, you use a remote. A remote just means you don't have to touch the TV. You can be from a distance, and it still connects, right? So remote sensing, when we're talking about geography, right, we're talking about from space, right? It's a remote or distant thing. You got the satellites way up in space, and they shoot beams down. I don't know how all the science works, but it bounces things back, and it gathers this information remotely from a distance. Okay, so there's 2 main things. You can use what's called GPS, or global positioning system. It tells you where in the world you actually are, and then you have what's called GIS, geographic information systems, and that takes different types of maps and it like stacks them together. We can take a look at this. It layers maps. So one layer could be, the roads. One layer could be landforms. One could be amount of people that are living there, right? One layer could be the amount of rainfall in a year, and you can like stack all those maps into different layers, and you can once they're overlaid, you can see if there's any sort of connections. So that's called GIS. Okay. So, sorry that was very quick, a lot of information to get through. But again, if you ever have any questions or you need any clarifications, please reach out to me, and I will help clarify things, okay? I'll try to explain it in a different way. So, thanks again, and make sure you write all this good information down.